All right. Hi, everyone, and welcome to No Limits in the Browser with LuciadRIA. So my name is Robin Houtmeyers, and together with my colleague Glenn Croes, we will talk about LuciadRIA, Hexagon's solution to create high-performance geospatial apps that run in your favorite browser. So LuciadRIA stands for Luciad Rich Internet Application. And we'll go over a few of its strengths and capabilities and also highlight the advancements in the latest release. So LuciadRIA is actually part of the Luciad portfolio, which includes geospatial software components for real-time location intelligence and situational awareness, both in 2D and 3D. So it targets multiple environments, including browser, but also desktop, mobile, and server. But all components have a common goal, namely to help you as a developer create a geospatial application fully tailored to your own requirements. So a core vision behind LuciadRIA, and in fact of the complete Luciad portfolio, is bringing your data together and provide you with a single operational view. So this can be any data source or data type, including train, imagery, vector features, real-time information coming from sensors, 3D meshes, point clouds, and even panoramic imagery. And as you can see in the pictures here, this can be applied in many domains, such as smart cities, safety and infrastructure, logistics, maritime, aviation, architecture, and much more. So to show this in practice, you can see here a LuciadRIA demonstration that combines a set of data sources around San Francisco. So we have some base layers consisting of satellite imagery, train data, and also 3D meshes of the city. Additionally, we also have bus line trajectories and even real-time bus movements. And you can also really delve into the scene by integrating panoramic imagery, in this case captured with Leica laser scanner technology from Hexagon Geosystems. And next to all this location data, you can also integrate attributed information coming from sensors or prediction models, for example, to show the impact of noise pollution. So LuciadRIA enables you to visualize and analyze all these data streams in 3D with desktop-like performance by leveraging HTML5 and WebGL technology. I would like now to switch over to a live demonstration of a recent LuciadRIA application. So here we are looking at a 3D city model of Delft, a city in the Netherlands. And the data is provided by the HXDR digital reality platform. And next to visualizing this data, you can also really interact with the 3D models. To show this to you, we can do some experiments. For example, we can do measurements. We have here this central market square where we could do some length measurements. But we could also calculate the height of this church. Or we could move to one of these houses here next to the square and calculate the surface of one of the roofs. And I can do this by simply clicking on the edges of the roof, and I can immediately see the resulting area. So an example use case here is, for instance, to know how many solar panels you can place on the side of the roof that faces the sun the most. Next to these measurements, I could also do line of sight calculations. So for this, I can simply click here on a point on my map, for instance here, the center of the market square, and the green areas immediately indicate which areas I can see from my observation point. And logically, when I would move to a higher location, for example, we have here the City Hall of Delft. If I would place myself here on the roof, it's clear that I can see much more of the environment. And last but not least, we can also do intersection calculations. Again, I can click on any point on the map, for instance, again in this central square, and this gives me an intersection plane that I can move and rotate in 3D. And through this additional view here on top of my map, I can immediately see the outer perimeter of all the buildings that intersect with my intersection plane. And as shown before, I can also do some measurements here by simply clicking on a few points and do some horizontal and vertical measurements. So as you can see, you can do much more than just visualizing your data. You can also really interact with the 3D models and do some analysis. We'll also come back to that later on, but first I would like to hand over to my colleague Glenn, who will further highlight LuciadRIA and also its focus on developer and user experience.
Thanks, Robin. So LuciadRIA is a library that's used in web applications, and especially for web developers, third-party libraries can be real liabilities. Experienced web developers know the pain of dealing with third-party libraries all too well. For example, a library that you depend on may completely change its API, making it difficult to upgrade, or the maintainer of the library might suddenly stop maintaining the library, or documentation is lacking or non-existent, or libraries might be incompatible with each other, sometimes in very subtle ways, etc. These frustrating issues are often referred to as dependency hell. Luciad's vision on developer experience aims to avoid these issues. We want LuciadRIA to be a library that you can depend on, not a liability. We do this by offering a stable API with a minimum of incompatible changes across releases, even major ones. And if we ever do introduce incompatible changes, we document them clearly. We have a fixed release schedule of 2 major releases per year, with minor patch releases every 2 weeks. LuciadRIA has a proven track record. It has been around since 2012, and as shown by Robin, it has been used in tons of projects and domains ever since. And I can assure you it will be around for a long time to come. LuciadRIA itself has no third-party dependencies. All it needs is a browser. This makes sure that LuciadRIA plays nice with other libraries used in your application. You still might end up in dependency hell, but it certainly won't be because of LuciadRIA. So when you open a LuciadRIA release package, you'll not only find the API itself, but also over 40 sample projects that show you how to integrate LuciadRIA in your web application. They also show you how to use the API to visualize the data that you want. Also included in the release is a ton of documentation. Of course, there is the API reference, but besides that, you'll also find tutorials, how-to articles, and frequently asked questions that you can use to find answers to your questions. On top of that, if the documentation does not answer your question, you can ask your question by emailing support. Technical questions are answered by the developers themselves. They are in control of the code, so they can provide you with the right technical advice or implement a fix in case of a bug. Aside from all these non-technical policy and documentation benefits, we also make sure LuciadRIA is up to snuff with the latest and greatest in web technology. In one of our more recent releases, we added out-of-the-box TypeScript support to LuciadRIA. The goal was to further elevate the developer experience. I'll elaborate on this in more detail. So first, I'll briefly explain what TypeScript is. It's a superset of JavaScript. This means that all JavaScript is also valid TypeScript. And TypeScript only adds type information to JavaScript. JavaScript is a dynamically typed language. This means that you'll only find issues in your code once you run the code. By adding static type information to JavaScript, you'll catch some of the errors while you're still writing the code. So you don't have to go back and forth between writing and running code. As an added benefit, your IDE can help you write the code because it has the extra type information from TypeScript. So Why is it useful for LuciadRIA to have TypeScript support? Well, LuciadRIA is quite an extensive API. You can do a lot with it, and there are a lot of customization options. TypeScript helps you use that API correctly. It will provide hints on how to use the API and warn you if you're doing something wrong. In the video, I'll show you how it helps you in practice. In the example, we'll be creating a WebGL-powered LuciadRIA map. So, as we're writing code, we only have to partially type the name of the class that we want to use, and our IDE already gives us an autocompletion hint. Once we accept it, it will also import the right module in our code. We can inspect the documentation of the class inline, so we don't have to switch back and forth between a documentation website and our IDE. It states that we must specify the identifier of the HTML element of our map, which is simply called map in our application. Next up, we specify some options for our map. One of them is the map's coordinate reference. LuciadRIA supports both 2D and 3D maps. The type of map depends on the coordinate reference. Here, we will specify a 3D coordinate reference, so we'll end up with a 3D map. We also want to set the color of our 3D globe to red. We see that there's a globe color option, which is a string, so let's use that. We don't know what the exact contents of the string would be, but by looking at the documentation, we see that it's a CSS color. So it all looks good. There are now no errors, but if we would introduce an error, then we see that TypeScript will immediately flag it as an error. It points us back to the correct spelling of the reference option. For developers that are already used to a statically typed language like Java, these things may seem obvious. However, if you're using JavaScript or any other dynamically typed language, your IDE simply cannot give you this level of code assistance. With TypeScript, it can. So to give a taste of the LuciadRIA developer experience, I'll be giving a small live coding example. In the example, we'll be visualizing some ECDIS charts. ECDIS is a map standard that ships use for navigation. You can find these maps on consoles in the bridge of the ship, where the ship is commanded. So on the left here, you'll see an ECDIS map in the real world, and we'll be adding such a map to our web application. All right, time to get technical. So I have created a small LuciadRIA sample project in a release. So we have our samples folder, and as you can see, there are already quite a few samples out of the box. And I added a new sample. It contains a small HTML page with a map HTML element that covers the entire page. I also created a TypeScript file with the code that we just saw in the example. We have a Webpack development server running, which hosts our web application, and if we open it in the browser, we see our 3D red globe, but there's no data on it yet. So I went ahead and set the data up on a WMS server. We just need to consume it in LuciadRIA. We know the URL to the server and the name of the layer. And now we want to visualize that data on the map. Let's pretend that I'm not a LuciadRIA expert. How do I get started? Well, a great place to get started is our developer platform. On this platform, you'll find all of the documentation about our Luciad portfolio, including the API reference and tutorials. So let's try searching for LuciadRIA WMS layer. The second search result points us to a guide that tells us step by step how to create a model and a layer and visualize it on the map. For now, we'll just do what any expert developer does, which is copy-paste the code into our application. We get some errors that our IDE provides automatic fixes for. We just have to accept these. And then we see we still have to fill in the URL to our server and the layer name. And now if I save, I'll see that something changed. We see a black map because the data is situated in the United States. And to fix that, we'll zoom in to, for example, San Francisco. I'm a LuciadRIA newbie, so I don't know how to zoom in a LuciadRIA map. So let's search developer platform. Zoom area. Navigating the map, fitting, panning, and zooming. Sounds like exactly the thing we want to do. And here, fitting to a predefined area, we want to fit to San Francisco. So let's copy that code. Fix the import errors and change the coordinates to that of San Francisco. We don't need it to be animated because we want to fit immediately when the application starts. And now when I save, the map is fitted to the San Francisco area. And indeed, I can see the maritime navigation chart. The map is currently 3D, which does not make a lot of sense for a maritime application as the ocean is pretty flat. So let's change our map to something that makes more sense, a 2D map with a Mercator projection, which is classically used in maritime navigation. So I'll change the coordinate reference of the map and save. The page will reload. And now we have a 2D map. Note that I only changed the coordinate reference and I didn't have to change any other code. Okay, enough programming for now. I want to talk about user experience in LuciadRIA. So while a good user experience is a result of many factors, having your application perform well and keeping it responsive is absolutely critical. There is no better way to frustrate your users than by keeping them waiting or letting them interact with a jerky, jittery application or map. LuciadRIA aims to always keep the map responsive and running at a fluid 60 frames per second on capable devices. Recently, we also started leveraging WebAssembly. The main goal was to reduce load times of our map and the applications that use them. WebAssembly is a fairly recent web technology. It is a binary representation of code, just like Java's bytecode. This representation is more compact than JavaScript, which is text-based. The binary code is smaller, so it gets downloaded faster, and it's parsed faster by your browser, resulting in shorter loading times. In the table, you can see the benefits that we measured when we switched to WebAssembly. We've almost cut our bundle sizes in half, and LuciadRIA maps in applications now start and load a lot faster. Runtime performance has improved slightly. In most applications, we've only seen about a 5% gain in frame rate, and only in synthetic benchmarks, we've seen a frame rate gain of up to 25%. So the biggest benefits are in application start times. Shorter start times means happier users. As an added benefit for developers, Webpack compile times are a lot faster too. We've seen some applications compile up to 5 times faster since we switched to WebAssembly. Another strength of LuciadRIA is that we allow the customer to create a tailor-made user experience in their application. First of all, you can use the UI framework of your choice. LuciadRIA has no preference for any of them, and we've already integrated LuciadRIA with the most popular UI frameworks around, like React, Angular, and Vue. You can also tweak the map visualization itself. In this video, you see a demonstration of some map effects that you can enable on LuciadRIA maps. We show how to turn on shadows, ambient occlusion, sunlight, atmosphere effects, depth of field, and some color filters. So you can really make the map look the way you want in your application. The last thing that I want to show you is that customers can really tweak the way user interacts with the map. For example, in the Delft 3D City app that I showed earlier, our customer implemented a custom navigation mode for their application. So they wanted the camera to stay really low to the street level, and when the user clicks on any point on a 3D mesh, the camera will move to that point. You can see that the application is running at a very steady frame rate, and they even allow moving across rooftops. They can change the height of the camera and continue moving down the street. All right, so that's all for what I had to show. I've explained how we deliver a great developer experience to our customers and how we can enable them to deliver a great user experience in turn.
All right, thank you, Glenn. And as you indicated, the WebAssembly improvement really ensures fast loading of heavy 3D web applications. So here I have another example, and we're currently looking at an industrial site represented by a 3D mesh. And we also have here some panoramic imagery. And one of the new LuciadRIA advancements is the ability to visually swipe between multiple data layers. So to show this to you in practice, I can enable this swipe controller. And let's, for example, compare our panoramic imagery on the left and the 3D meshes on the right. So through this vertical slider here in the middle, I can smoothly compare both data layers. So an example use case within urban planning could be the comparison of multiple data captures at different dates, for example, to discover potential construction violations. So as shown before, we can also do measurements. For example, we have here this building in the background. We can do some orthogonal measures by simply clicking on some points and immediately getting some information about the horizontal and vertical distances. And last but not least, we can also integrate this fairly static data with real-time attributed information coming from sensors. So here at the top of this platform, you can see this cylinder, which is actually a container of a chemical substance. And I can simply click on it and see some properties. These include static properties like a component name, a serial code and type, and total capacity, but there is also some real-time information there. So I have an up-to-date view on the fill rate and also on the last maintenance date. So this combination of both static and dynamic data really makes this a smart site application, helping you to manage a site in an efficient way.
Thanks, Glenn. Thanks, Robin, for this nice presentation about the Luciad portfolio. Are you guys interested in receiving comments and feedback from the audience? And if yes, what is the best way for them to contact you? Robin, what is your opinion?
Yeah, I think that feedback would be very interesting for us. Glenn and I love talking about LuciadRIA and our products. So I think they can best post their comments below the video in the comments section, and we'll be happy to respond to them.
Fantastic. Glenn, does the same work for you as well, or do you want to drop your email address? What do you prefer?
Absolutely. I'm always happy to answer any developers' questions. They can post their questions in the comments or send an email to the email address on the screen.
Fantastic. Thanks again for your time and for this nice presentation. And like Glenn and Robin pointed out, if any of you have any questions, then feel free to post them in the comments section or reach out to them via this email address. Thanks, everyone.
Thank you.
Okay.